through A and B and multiply that out. Okay? So you multiply that out. What we're going to then do is undo that. Somebody here. So we are taking that formula on A and B. Go ahead and multiply that together. Put that into standard form. And then we'll do the factoring portion of things. Talk about keep saying word factoring. What's that actually mean for us? Yeah, actually have like a 5-minute pass or something around early. Do you like a 5-minute pass out early or anything? No? Yeah. Maybe this is your first day back, guys?
Yeah.
What's that? Alright, we'll get in that. Alright, taking that and multiplying it. Okay. That's what you're doing real quick. So we always put things in standard form. As we multiply, add polynomials, it's got to be in standard. As we get ready to do factoring in just a moment, same thing. You guys go to make sure it's in standard form. Clean it up, move things around if you need to. All right, so on that first one here, just as a quick review of things that we've talked about so far this year. When we multiply here, what do we get first? Negative what? Yep, 6g to the 5th. Remember, we're adding those exponents. And then on the other term, we're getting what? Okay, can we do anything more with that? Nope, so we are good to go. It's in standard form. And what is, again, the name of this polynomial? 5th degree. And another name for 5th degree is? 5th degree is a quintic. 5th degree, what do we just say? Binomial. And like we said, it could also be called a quintic. All right. Take the other one if you haven't done so yet, and multiply that one on through. And then over the next 2 days, today we're going to undo question 1. And then tomorrow we will start undoing the second question, there, letter B. All right. And then we'll throw everything out there and then try to practice it out to get not just good at it, but great at it. As you distribute. Okay. You're going to get into a lot of multiplying all over again starting tomorrow. So as you multiply that out there, all right, should be able to be pretty quick at that part this time of the game. Again, check me as well. Check always my multiplication and division, whatever. Somebody got 9x squared. And then, yeah, what happens to these two linear terms? Cancel out. So we end up with a quadratic, correct, and binomial. Okay, starting tomorrow, we are going to focus on quadratic binomials and quadratic trinomials. We're going to focus on quadratics.
Is this the homework?
No, that's all the notes.
So like, there you go. Like this.
So we're going to focus all on quadratics starting really tomorrow. Today could be a mixture of whatever. All right, so let's go ahead and keep going with this. Let's get into finally our notes. We're going to focus on the title of today's lesson, actually. It's called GCF, the greatest common factor. Now, at some point down the road, when you start learning about LCMs, LCDs, GCFs, that's sometime down the road. All right, we're going to focus on the GCF here today. What I'd like you to do is, we've done some geometry throughout the school year mixed with algebra. Find me the area of that blue figure, and then find me the area of that orange figure. How do you find the area of a rectangle? Base times height. So what do we have here? 2z times 1z. And what's 2z times 1z give you? 2z squared. 2z squared. So the area of this blue one, using our geometry here, this is 2z squared. What do we get on the other one then? 2z times 8. Yep, 2z times 8 and 16z. Okay. Now, going to do that again. But what have they done with these two triangles? They've pushed them together, right? So now what are we going to do here to find this area? 2z times, yeah, how do we write that length up there then? Somebody said it? Z plus 8, right? Do not say, I think one of the mistakes I usually see is students say accidentally 8z. What does it imply is in between 8 and z here? Multiplication, yeah. But what are you doing though? You have to add those. So the common mistake is to say 8z, that's incorrect. It is actually z plus 8. And because it's z plus 8, it's two terms, what we need to do with the z plus 8? Yep, distribute it. We got to put that in parentheses. That is, again, one of our keys as we work through here. Now distribute. Okay, we just did that with the warm-up, right? Take that, multiply it on through, and we end up with 2z squared, right, plus 16z. And as we can see here, if we took questions 1 and 2 and looked at the commonalities of it, it's the same answers, right, except we found the one separately with the other one, and then together we found the area there. If we were to add these two areas together, we get the same thing, right? So what's hiding in there is what we say some type of common factor in these two rectangles, okay? We have some type of common factor hiding in both of these rectangles. What is that kind of common factor that both of these questions have in common? Not just 2, 2 and a z. 2z is in both of those, right? And that 2z is what we call the GCF, the greatest common factor. So when you just told me 2, you just told me a common factor. I am looking for the GCF, the greatest common factor. So you want to look at both the numbers out front, the coefficients, and also keep in mind the variables as well. That creates the greatest common factor, the GCF. Now, let's keep on here with talking about the GCF and really get into it. Right down here below, okay? The area of a rectangle is given by 3a squared plus 3a. We want to find the length and width of the rectangle, and then how many possible answers are there for that challenge there to spread? What's the answers you find? So what I'm trying to figure out is what are possible lengths and widths here that gets me a 3a squared plus 3a. So kind of think about up to the top there. What could I rewrite that, undo it, to get me a rectangle with a length and a width right there? Caleb, you have a suggestion?
3a.
Okay, now let's start off with that suggestion. He is saying a 3a. If I want to now take and think in your head as what we did up above, undo multiplication, because that's what we did up top, right? We did multiplication. What undoes multiplication? Division does, right? So Caleb says, hey, this had to be 3a. What did that width have to be in order to get that area? What had to be there originally? I took out a 3a. We're undoing multiplication by division. What's 3a squared divided by 3a? 1a. All we're doing is going back to your 5th and 6th grade exponent skills. You're dividing by 3. A squared divided by a gives you 1a. And plus 1. We took a 3a away from both of these terms. 3 divided by 3 is 1, and a divided by a cancels out completely and gives you a 1. So with Caleb suggesting us doing a 3a first, that has to go with an a plus 1. How can we check to see if we're right? Multiply it back through. If we multiply that back through, where should it go? 3a squared plus 3a. Now, usually I also have some students tell me not 3a squared. Some students just tell me that 3 that they see in front of it. So let's say I erased the 3a, the a plus 1 plus it, and I only pulled out a 3. If I only pulled out a 3, okay, now divide. Well, what's 3 divided by 3? Back to still 1, right? Do I have any variable a's to divide out? No. So another possibility is to have a dimension of 3 by a squared plus a. Now what we say right there is it's a common factor. What Caleb suggested to start off with is I don't say the best one, but it's the GCF. It takes everything in there. He took the number and the variable at the same time. There's another possibility we can have out there. What if he didn't tell me the 3? Not just no, let's look at the variable, I should say. You see that they also have a's in common. Let's take out an a. What if I take out an a? Now, what would I have for that specific width? Divide by that a. Now, I don't have anything to divide with the 3 this time, but what's a squared divided by a? 3a. And what's 3a divided by a? Just 3. There's a third possibility out there. The two that I usually see is the first two options. Okay, but there's 3 possibilities out there. These all work to give you that same area. But we like to be kind of all on the same page, right, in math. So what we want to focus on today is trying to get all on the same page by looking for what we say is the GCF. Okay, so the GCF. Let's start finally doing that here on the next page. GCF here, we want to look at the largest number or variable that will evenly divide into every term. And if all those terms have the same variable, we'll talk about it. You can only take out the smallest amount that is there. So we'll look at the exponents as well. So let's finally just get into doing some practice with that. And let's flip it to the next side. I've got a little just kind of a step here for you to work out that problem. Let's go ahead and work out letter A. Okay. So we have ourselves a what? 4th degree trinomial. Your first thing is always to make sure, no matter what we do today, tomorrow, this week, you always got to be in standard form. So always check to make sure you're in standard form. We're good to go. Now what you want to start doing is look at those numbers, the coefficients. 2, 10, and negative 6. What is the largest number that will divide into 2, 10, and negative 6?
6.
Just hold on, just with them for a moment. It's just, yeah, it's just 2, right? So to start off with the GCF, I'm going to start by looking at those numbers, the coefficients, and I look at that 2. Okay, bring out a 2 there. Because 2 divided by 2 works, 10 divided by 2 works, and 6 divided by 2 works. Then I heard an X from you. First thing is, all these terms have to have an X up there. If I didn't have an X here, can I take away something that's not there? No. So you got to make sure that they all have that variable up there. They do. And then again, you can only take away the smallest amount there. So I heard some of you say 2x. Why am I not taking away, say, x squared? Do I have enough x's over here to take away from it? No. So you can only take out the smallest amount there. And that gives you what we say is the GCF. Now show me what you have left over. Undo now that multiplication. You just brought out a 2x from those 3 terms. So to undo that multiplication, what are we doing? Yeah, you're undoing the distributive property. You're undoing multiplication. And the inverse of that is division. And these are nice numbers to work with. Okay, let's divide now. Took out a 2x. What's the first term give me? 1x to the 3rd. Okay, 2's cancel. X to the 4th with that gives me 3 left over there. You subtract them, right? That's always the case with exponent rules. For the next term, what do we have left? 10 divided by 2 is 5, right? And I heard just say x. And then the last term, watch your negative. Negative 6x divided by 2x is minus 3. The 6 divided by 2 and the x's cancel out completely. And that is now what we say is our factored form. When we say factored completely, what that means here is bring out that GCF and then show me what you have left over when you took out that GCF. Yes, Sam?
With ones like F and H, are you wanting us to solve some then factor?
No solving's occurring today. So we'll talk about F here. F is again until special case, okay? But there's no solving occurring today. Are there any equal signs up there? Solving goes with equal signs, no solving today. All we're doing is
You want us to distribute that back.
yes and no. I'll make your life easier. Okay? I'll talk about that. Alright, I'm sorry, Sam. You can try distributing and see what you get, and then by the time we get to F, we'll see if we get the same answer. Alright, let's take a look at letter B. Let's start off again. 4 and 12. What's the largest number that 4 and 12 can be divided by? 2 works, right? But take the largest one. As I see Parker up there, he held up 4. If you say 2, you got a common factor, not the greatest, and I want the greatest. So it's a 4 starts it off with. X to the, how much can I take out? X to the second, because the smallest amount there is 2. I can't take away anything I don't have enough of. All right, there's my GCF. Divide it. Show me what you have left over. Okay, 4x cubed divided by 4x squared gives me what? Yep. 12x squared divided by 4x squared gives me, divide, gives me 3, right? That's it. How can I check to make sure I'm right? Double distribute back on through, and what should it do? It should go back to the original polynomial. Sam?
Let's say if we did like 4x times x squared plus 3x. Is that
No. So that is again the common factor. It is not the greatest common factor. So if you didn't hear what Sam had suggested, what if we just did 4x and had left over what? X squared plus 3x? I think that's what you said. That's not factored completely because there's still another common factor in there, right? So you always want to bring up the greatest common factor. All right, next one there. Got a couple of those underneath our belt. Okay, small things in math. We know math sometimes is straightforward, and there's always sometimes a little bit of twist to it. All right, as we look at letter C here, let's just focus on the 2 and the 5. So what number divides into 2 and 5? 1. All right, that doesn't really do anything for us. How about the variables? How many A's can I bring out? Okay. Now I put a small twist on that. What's my lead coefficient here? Not 2. Negative 2. All right, typically, if the lead coefficient is negative, we typically bring out that negative. So what did you just say a second ago? 2 and 5, common factor was 1. But because the lead coefficient is negative, we typically bring out a negative with that. Is that always the case? Most of the time it is. All right, you'll see sometimes maybe not, but for the most part, if you see negative to start off with, bring out that negative. Now show me what you have left over. Divide by negative A. Watch your arithmetic there, watch your negatives, and what do we got? 2A, and then what? Plus, yeah. Now when you bring out that negative A, that negative is going to flip all your signs then. Okay? And as we progress in the second semester in Algebra 2 next year, bringing out that negative cleans up the inside a little bit with not having to worry about those negatives all the time, so get into that habit. All right, down below, let's keep going on here. On the next one, letter D. Right, started off 40, 24, and 12. What's the GCF there? Largest number that goes into 40, 24, and 12.
4.
Okay, yeah, 4 starts it, right? 4 works in all those. Anything larger? Yeah, no. So now we look at the variable, and x, we can take out the smallest exponent there. Show me what you have left over. GCF is good. Do you need to show that division of 4x every time? Nope, but I just showed it to start off with. So just make sure you not divide. 40 divided by 4 is what? 10x to the cube. And then next one gives me what? Negative 6x squared. And then the last one gives me plus 3. And if I just kind of look at what's inside those parentheses, I should not see any common factors still hiding there because I already brought out that GCF. Okay. All right, letter E. They don't have neither one of, or sorry, both of them don't have the variable, right? So I can't bring out any variables on this one. But what I do want to bring out is that -1. So if that lead coefficient is negative, typically we bring out that -1. Now, is there a number that 2 and 7 divides by nicely besides 1? No. So the only thing I can say for this one here is the GCF is a, that's it, yeah. And when I bring out that -1 now, all that does is flip my signs to 2v plus 7, distribute on through, check it. But because that 7 doesn't have a v, I can't take away from it. Okay. Now, do we usually have to put a 1 out front like that? No. How do we usually just see it? Like that. Okay. All right, Sam. Let's take a letter F here with you.
So I know my answer is right because, or it technically, in my head it is, but so
Okay.
I factored or I distributed got x squared plus 12x plus 35.
Okay.
But none of them divide by a good number.
Okay.
Other than 1.
So let's do this the quick way, and then we'll come around and talk about
I think it's
sometimes traps we fall into.
maybe a one.
Okay. When I look at this, I just take a step back. What is something that jumps right at you at letter F? What do they have in common?
They all have
Lucy?
7 plus x.
They all have that x plus 7, right, in parentheses. So what we've been doing so far has been common factors, GCFs, that have been one term, a monomial, a monomial, a monomial, a monomial. That is what you come across 90% of the time in Algebra 1. And as you go into the end of Algebra 1, Algebra 2, we start getting into a little bit bigger, greatest common factors. Staring you right in the face is the GCF. What do they both have in common? X plus 7. So I'm going to take out a binomial this time. They both have x plus 7. Now, by taking that out, if I remove x plus 7 from here, what am I left with on the first one? Just say x. And if I take it away from there, what am I left with? Just a, okay? That's the quick version of that. The GCF is staring you right in the face saying, hey, look at me, I'm special, I'm the parentheses, take me out. Now what Sam was trying to do is what we're going to talk about tomorrow. Okay? He had thought, which makes sense. And that's usually, I usually would pause and let everybody kind of fall into that trap. Distribute the x, and he ended up with x squared plus 7x, and then 5x plus 30, what, 5? And then we combine like terms, and I think this is where Sam was, I think, stuck at that. X squared.
The answer is not a good answer.
So it's, yeah, it's probably not. So x squared plus 12x plus 35. Does this trinomial have anything in common? Doesn't have an x. 1, 12, and 35. Is there a number in there? No. Now we're stuck. We're going to talk about how we deal with that trinomial tomorrow. When you don't have a GCF, we have to change around our factoring skills, and that's where I hit you hard tomorrow. Sam?
Explain it now.
No. No, I'm not gonna. I don't want to confuse anybody. I will talk to you if we have time at the end of the period, Sam. Okay. All right. Let's look at letter G now. A lot more going on. I got some extra variables in there. Who the heck cares? 12, 18, and 10. GCF for 12, 18, and 10 is 2. Go with the M's. How many M's can I take out? M4, M3, M to the first. So as Caleb said, M to the first. And how many N's can I take out? Smallest exponent is 2. That works for me. And there's your GCF. Show me what you have left over. You took out 2mn squared. So now go ahead and divide it. All right, just watch your arithmetic. Easy to make mistakes. What do we got? 6m to the third. N squareds are gone. And then negative what? 9m to the second. N. There's one n left over. And then what? Negative 5 M and N's are gone, correct. So whatever's inside that quantity, I do always a quick glance. Do I have anything in common still? No. 2m n squared was my GCF. Gets a little bit more with two variables, but nothing really changes around. Yes?
I'm confused how you got M for the second. Like
N?
on 9.
No.
Yeah.
Right here?
Yeah.
Okay, it starts off with m to the third, right?
Yeah.
And how many m's did I take out? Right? I took out one m. Plus m.
Oh, okay. I see.
You good?
Yeah.
Yep, 3 minus 1. Well, see, that's where I'm getting that m squared. Okay. These are the good questions to ask now. Okay. Don't just sit there like, where's that number appearing from? It's not magic. You know, for some people, math is magic. All right. Okay. How about letter H? What's staring you in the face, Sam? That binomial. So what I'm going to do is bring out that GCF. I'm not going to make my life painful here. I'm not going to distribute on through. I want you to see some of that structure, those things that pop out at you. 2y minus 3 is the greatest common factor, standing right in the face. And then if I take away 2y minus 3 from that first one, what are you left with? Y. And then on the other one, correct, minus 10. Tomorrow we'll learn how to deal with those, kind of. We'll make, this is the quick route to make your life easy, okay? All right, finish this off, because now we've done a couple of those, we've done all the big types of GCS we're gonna do. Last three that I have here, just a little bit of extra practice, 2 terms. Okay, 3, 9, and 12. What's the GCF for 3, 9, and 12? How many G's can I take out? How many H's can I take out? Why can I take out G's? Yeah, the last term doesn't have a G, right? Can't take away something I don't have. Take out that 3H, that sounds good. Show me what you have left over. Do I need to show that 3H there? Maybe the first time through. But once you get the hang of it, you can definitely keep track of that in your head. What do we have? 3 divided by 3 is 1. G cubed is still there. H's are gone. Negative 9 divided by 3 is negative 3. G is still there. H's are gone. 12 divided by 3 is 4. H's are gone. There we go. Okay. Last two there. Just a little bit extra practice. 16 and 72. What's the largest number for 16 and 72? As I say, this is one maybe where a calculator might come in handy just to start doing that division. 2 obviously will work for you. 4 will work. And then after that, may not be as obvious. Now Sam is saying 16 does. How many times is 16 going to 72?
8.
Not 8. And that's where we got our calculators, because I'm not thinking either. 72 divided by 16, does that work? Does not. 4.5.
Never mind.
Wouldn't it be
8 then. Oh, that's okay. I follow you there, Caleb. 8 is the GCF. So I try that 16 there, and it divided not nicely, 4.5. So I bring it down a bit, go with Caleb's suggestion of 8. Any A's I can take out? Any B's I can take out? Show me what you have left over now. Divide it. So what is that? 2A, right? And then plus 9, Sam is saying. That looks good to me. Check our work as well. It's easy to make silly mistakes. Call me out on it. All right, Sam. Call you out one more time. What's the GCF staring you in the face then? 3x. If I take that away from the first term, we're left with just x. And we're left with just 2. Correct. So when you look at these ones that we just finished up with, you get a binomial and a binomial. On the other ones, we got a monomial and some type of polynomial. These are what we'll then focus on tomorrow. How do I get binomials? They're not going to look like that. If they look like this, we want to use our GCF skills that we started today. And then tomorrow's where really the heart of the factory gets into it. So we start off with the first one, and then tomorrow we really get into it. So as I was telling you, All right. If you are